In this video, we are going to discuss about a project. Project name is Home Automation using blynk app. This presentation is given by Naru Chandrasekhar Reddy. Let's see what are we going to discuss in this session. First, first about C language. Next, introduction to IoT. Third, embedded system. Fourth, problem statement. Fifth, tools used in this project. 6. Output images. C language. C language was created by Dennis Ritchie in 1970s. C language has been established in very wide base of applications. There are many applications for the C language. It is mainly used in developing system software, OS kernel software, application software, embedded software development, etc. C language only contains 32 keywords when it's created. C programming is a mid-level language. Now let's discuss about the C language keywords. The keywords can be broadly classified as following. They are primary data types, user-defined data types, storage types, conditional, loop and loop control, and some others. In primary data types, we have int, long, short, signed, double, char, float, unsigned, and void. In user-defined data types, we have struct, type, def, union, and enum. Storage types, auto, extend, static, and register. In conditionals, we have go to, if, else, case, switch, and default. Loop control, for, do, while, continue, and break. Others, constant, size of, and alt. These are the total 32 keywords when the C language is created. Now let's discuss about the data representation. Number system. Type decimal, we don't give any prefix. Let's discuss it in 8 bits. In decimal it is 0 to 255. Octal is represented with the prefix 0 and octal number. 8 bits is range from 0000 to 0377. Hexadecimal. Hexadecimal has prefix 0x and 8 bits is ranging from 0x00 to 0xFF. Binary. It has prefix 0b and 8 bits range is from 00000000 to 11111111. 1 byte is equal to 8 bits. Size of the data type keywords. Char is of 1 byte, that is 8 bits. Short is 2 bytes, that is 16 bits. Int is stored in 4 bytes, that is 32 bits. Long is stored in 4 bytes, that is 32 bits. It varies based on the operating system we are using. No keyword size is more than 32 bits. The following equation is always must be true. That char always must less than or equal to short, less than or equal to int, less than or equal to long. Operators in C. The operators in C language are classified into 6 types. They are arithmetic, relational, logical, bitwise, assignment, and some other. Arithmetic operator means they are arithmetic operations. They are plus minus into divide by modulo increment and decrement. Relational operators tells about the relation, or to give relation we use this: less than, greater than, less than or equal to, greater than or equal to, not equal to. Logical operators. Logical operators are three: and, or, not. And means if both the conditions are true, then only the statement will be implemented. Or means either one of the condition is true, the statement will be implemented. Not. If the condition is true, the statement is not implemented. If the condition is false, statement is implemented. Bitwise operators. These are operators are used in bits. And, or, x, or, not, left shift and right shift. Assignment operators. Assignment operators means operation performed and assign it to a value. They are equal to, plus equal to, minus equal to, into equal to, divided by equal to, modulo equal to, and equal to, or equal to, x, or equal to, right shift equal to, left shift equal to. And there are some other operators. They are comma, conditional, dot, and etc. Now let's discuss about the introduction of IoT. The term IoT means Internet of Things. The term IoT was first coined in the year 1999 by British entrepreneur Kevin Austin while working at Procter and Gamble. The IoT is a network of interrelated devices that can connect and exchange data with other IoT devices and the cloud. That means IoT is nothing but a network of devices that can connect and exchange data with others and the cloud. IoT devices are typically embedded with technology such as sensors and software. The things in IoT can be any machine or physical object that can communicate with other machine by connecting to the internet. These are categorized into two types. They are things in IoT. The thing in IoT is nothing but any machine or physical object that is able to communicate with the other by connecting to the internet. They are categorized into two types. They are object with intelligence or smart objects. Example: microcontroller, smartphone. Object without intelligence are non-smart objects, sensors and actuators. Let's discuss about applications of IoT. There are very wide range of applications for IoT. Some of them are wearables, that is we are wearing like smartwatch, etc. Smart home applications. By using IoT, we can automate the objects at home, that is controlling using the mobile app. Healthcare, smart cities, agriculture, industrial automation, hacked cars, smart retail, smart supply chain, smart farming, and many other etc. There are some challenges in IoT implementation. There are lack of standardization, means there is no standard procedure for IoT implementation. Scalability. Scalability GUI, graphical user interface. GUI means addressing issues. Nowadays there are increasing more and more electronic devices, though there is a problem in addressing all the devices. Understanding the big data, address acquisition, handling network traffic patterns, security or privacy issues. When everything is connecting to internet, there may be a problem of security and privacy. Legal, regulatory or rights, emerging economy and development issues, interoperability. These are the challenges in the implementation of the IoT, that is Internet of Things. Embedded system. System. System means the systematic arrangement in which all its components assemble to work together according to set of rules. That is, system is nothing but a systematic arrangement of components work based on the set of rules. Example, watch is time displaying system. Embedded systems. Embedded system is a combination of software and hardware. Embedded system is designed to perform a specific task. The task must be completed in a given time. Example, washing machine, microwave, car keys nowadays, etc. Let's discuss how does an embedded system work. Always function as a part of complete device. That means embedded system is not a complete device. It is always a part of complete device. Embedded systems are low cost, low power consuming small computers that are embedded in other electrical systems. Generally, they consist of processor, that is control unit, power supply for working of the components, memory for storing for storage purpose, and communication ports. Memory is divided into RAM and ROM. RAM contains the data and ROM contains the program. Because we don't change the program, we don't change the program of embedded system. It once it is programmed, it is fixed. But data is varies. That's why we store program in the ROM, that is read-only memory, and data in the RAM, random access memory. Types of embedded systems. There are few basic type embedded systems which differ in their functional requirements. They are mobile embedded systems. Mobile means we can carry that, move or something like that. Digital cameras. Example. Networked embedded systems, home security systems, and point of scale systems. Networked embedded system means they are connected to the network. Standalone embedded system means standalone means they work on their own. There is no requirement of the other. Example, a calculator or MP3 player. Real-time embedded system example is traffic control system. Embedded system can also be categorized by their performance requirements. They are small-scale embedded systems, that is 8-bit. 8-bit microcontroller, that means it can process 8-bit at a time. Medium scale, larger microcontroller 16 to 32-bit. Sophisticated scale embedded system often use several algorithms that result in software and hardware complexities. This is about the embedded systems types. The applications of the embedded systems are in various sectors. They are medical, office equipment, tools, banking, transportation, building, agriculture, space, radars, traffic signal lights, signaling systems. In medical, patient monitoring systems, ICUs, pacemakers, etc. In office equipment, printers and fax machines. Tools like millimeters, oscilloscope, GPS, global positioning system, ATM. ATM means automatic teller machine, statement systems. In transportation, planes, trains, boats, automobiles, engine management, trip computing, airbags, car alarms, ABS. Building system, we use a embedded system in elevator, heater, AC, lighting, key card entries, locks, alarm systems, and many more. In agriculture, feeding systems, milking systems. In space, we use embedded system at satellite system. Now let's discuss about what are we going to do in this project. Home automation using blynk. Requirements: change the garden lights brightness of the surrounding, that is nothing but the sunlight brightness. Control temperature in a room using the blynk app. Control inlet and outlet valve of a cereal tank using the blynk app. Garden lights control. Read the LDR sensor value based on the reading from the LDR. Vary brightness of the LED with the resembles controlling lights based on the availability of sunlight. That is, we can requirement number one: garden lights control. Inputs are LDR sensor process. LDR sensor senses the value and we vary the LED brightness using that sensor value. Outputs are changing the garden lights brightness. Temperature control system. Temperature control system consists of heating resistor and LM35 sensor cooler, which resembles the control system at home. Read the temperature from LM35 and display it on LCD. Control the temperature of the system by turning on or off the heater and cooler through the blynk mobile app. Requirement number two: temperature control system. Inputs are temperature sensor, that is LM35. Process: read temperature from sensor LM35. Output: we have to display the temperature sensor on a gauge widget on mobile and also display on the CLCD. Cooler. Requirement number three: cooler control system. Inputs: button widget, that cooler button on a blynk IoT app. Process: detect the change in the logic level, that is the cooler button is on or off. Output is change the cooler is on or off based on the button widget. Similar to cooler control system. Requirement number four: heater control system. In heater control system, we use a heater button on blynk IoT app to change to switch on and off the heater control. Heater. Threshold temperature control, that is requirement number 5. Inputs: temperature sensor. Process: read and compare the temperature of sensor with 35 degrees. Outputs: if the temperature is more than 35 degrees Celsius, turn off the heater and send notification to the blynk app and display same on CLCD. Water tank inlet valve and outlet valve control. Read the volume of the water in the tank through the serial communication and display it on the CLC. That is, you have to read the volume of the water in the tank by the serial communication and display it on CLC. Control the volume of the water in the tank by controlling inlet and outlet valve. By sending commands through the serial communication, display the volume of the water in the tank on the CLCD. Requirement number 6: display the volume of the water in the tank. Inputs: serial tank. Process: read volume in the tank and send commands to serial communication. Output: display the volume of the water on the gauge widget of the mobile phone. Display the volume of the water on CLCD. Requirement number 7: inlet valve control. Input is nothing but the inlet valve button widget on the mobile app, that is blynk IoT app. Process: detect the change in logic level, that is check whether the inlet valve button is on or off. Output: if the button is on, turn on the inlet valve. If the button is off, turn off the inlet valve. Let's discuss again. If the button is on, that is logic high. Turn on the inlet valve by sending commands through the serial communication. If the button widget is logic low, turn off the inlet valve by sending commands through the serial communication. Similarly, we control the output valve control, that is requirement number 8. Inputs. Outlet valve button and blynk IoT app detect the change in logic level, process that outputs. If the button widget is turned on, turn on the outlet valve. If the button widget is logic low, turn off the outlet valve by sending commands to the serial communication. Requirement number 9. Control the volume of the water in the tank. Inputs. Serial tank. Process. Read the volume of the temperature in the tank by sending commands to the serial communication. Output. If the volume of the water is in the tank is less than 2000 liters, turn on the inlet valve and send notification to blynk app and the display same on CLC. Control the volume of the water in the input serial tank process. Read the volume of the water in the tank by sending commands to the serial communication outputs. If the volume of the water in the tank is equal to 3000 liters, that is the tank is full. Turn off the inlet valve and send notification to the blynk mobile app and display same on CLCD. The tools we used in this project, they are Arduino IDE. In Arduino IDE we installed two libraries. They are Liquid Crystal I2C and blynk app, blynk library, and Pixim Lab. It is a simulator of the Arduino. In Pixim Lab, we used serial tank, Ethernet, shield, temperature system, LED, LCD, and LM35 sensor. Virtual serial ports. This is for the communication of the serial tank to the Arduino. We use this serial port and created a configs and comms methods. Here COM means communication. Let's see the output image. The heater is turned on and before reaching 35 degrees Celsius and inlet valve turned on before reaching 3000 liters. Temperature T is equal to 32.23. Heater is turned on. Volume is equal to 2660 liters. Inflow is turned on. Heater is turned on. Inlet valve is turned on. After reaching 35 degrees Celsius, heater automatically turned off, and also after reaching the only liters, inlet valve is also turned off. That here see temperature is equal to 31.74. It turned off. Volume is equal to 3000 liters. Inflow turned off. That they are automatically turned off because we write code on the Arduino, that is sketch. Heater is turned off and inlet valve is turned off. See here, temperature is 34.18. That is if the temperature is reached 35 degrees and the heater is automatically turned off and it reduced from 35 to 34. See here, this is the volume of the water in the tank, that is 3000. It reached 3000 liters and the inlet valve is turned off. See here, volume is more than 3000 liters, so inlet valve is turned off. Temperature is more than 35 degrees Celsius, turning off the heater. Notification are showed on the IoT app. Turned off, turned off. Yes, this is inlet valve and this is outlet valve. It is turned off. Thank you for attending the session.